We're very fortunate to have with us Saad Gulzar, Assistant Professor at Princeton University. Saad has agreed to take questions as we go along. So please feel free to ask. For those of you that are joining the conversation via Zoom, please put in your questions to my colleague Sarat Pillai, and he can intercede on your behalf in the conversation as we go through. So without any further ado, Saad.
Thank you very much for having me. It's my first time at CASI, so very excited to be here. This is a project that is looking at the problem of crop stubble burning and air pollution in the broader South Asian region. So I've always wanted to do a project that combined Pakistan and India, and so this is my first foray into it. And the other angle for this project was that I wanted to work on air pollution because, you know, as many South Asians in the room would know, you go back to your home country, especially if the region happens to be in the north of India, in the Pakistani Punjab, you'll basically get a headache within a few days because the air pollution is so bad. We've all had struggles convincing our parents to turn on air filters, which never works. So I wanted to work on air pollution, and sort of this was the angle through which I worked on it. The other interesting story that we've all heard of is in the news media, which is Pakistan blames India for its air pollution problems, and India blames Pakistan. Eventually, I want to write a paper on who's right, but only if the results kind of align with my personal safety concerns. So this paper is going to approach that question also a little bit, but I'm not going to answer that specific question here. So it's called The Administration of Pollution, Evidence from Crop Burning in South Asia, and it's joined with one of your own, Jerma De Papa, who's now at Brown. So I think this isn't working.
Give him the
Yeah, it is. Yeah.
Okay. So just to motivate the talk a little bit, the problem of air pollution is increasing around the world, and nowhere is it more, problematic than in South Asia. This is a map of air pollution, and you can see that, in the northern subcontinent, this is a particularly big issue. We know that around the world, 42 of the 50 most polluted cities actually are in South Asia. And given that 1 in 4 people live in South Asia, it's a really big public health emergency globally that we need to address, and social scientists haven't really started thinking of this as a big problem or a research agenda. So we really need to concentrate on this more. And this is particularly a big issue because there are enormous health and economic stakes involved. Air pollution is associated with a number of diseases that I've listed here, but they also reduce the economic output of agents who are living under air pollution. To give you a sense of the magnitude of this problem, whereas COVID has killed about 6 million people in the first 2 years of the pandemic, air pollution is said to kill over 4 million people globally. And given that the problem is particularly pervasive in South Asia, a large number of these deaths are happening in South Asia. People in anthropologists, for instance, call this kind of a problem slow violence. The reason for it is because you don't see the effects of the killing agent immediately, and as a result, you can imagine that from a policy perspective, it's often easy to put the problem, kick the can down the line instead of addressing it head on right now. So we're familiar with a lot of common sources of air pollution, such as cars and industrial emissions. Something that's peculiar to South Asia is crop stubble burning. So let me give you a quick synopsis of what that means. After the Green Revolution in the northern Indian subcontinent, there was an increase in the amount of agriculture that was happening, such that now there was a rice and wheat cycle that was perpetuated in this area, such that there were multiple crop cycles happening every year. This increased the pressure on farmers and the agriculture community in general to really intensify the extent to which agriculture was happening. This has unfortunately increased the extent to which this phenomenon called crop stubble burning occurs, which happens when the rice crop is harvested around this time of the year, October-November window, and farmers only have about a couple of weeks to sow the next crop, which is the winter wheat crop, which did not exist before the Green Revolution. So in those two weeks, they need to clear the stubble of the rice crop and also sow the seed for the next crop. And so farmers have multiple ways of dealing with the stubble of the rice crop. They can use mechanized systems such as happy seeders that you may have heard of if you're into this literature. Or what they can do is they can buy a matchbox and light the stubble of the rice crop, so that they clear it with the fires. So here's a photo of a farmer doing that. The problem, of course, is that farmers can clear the stubble by burning it, and it's individually rational for them to do so because it costs just a few cents for them to do it. They need to buy just a bit of kerosene, matchsticks. But the externality from burning the stubble is borne by people who are downwind from it, and that's kind of what we'll study in this paper. In fact, people have shown that the externality costs a lot more than the economic gains that farmers enjoy at the individual level.
Just a quick question, Sal, which is that in the paper, you talk about these, and some of these happened quite some time ago, some of these developments. So I was just wondering, what is it just that they have become even more frequent over time, that we're seeing this rise and this emergence of this problem? Because the intensive agriculture, even the crop burning practice, a lot of that was many years old. So do we see any evidence that it's just that it's more and more and more, and that's been increasing, or has there been? I mean, I don't know if you can tell in the data like when that happened.
Yeah, so there are a few things. I mean, I think the data for this project goes back 10 years.
10 years,
and
yeah.
you can see a little bit of an increase over that period in the total number of crop burning activities that you can detect.
Mm-hmm.
However, I think there are a few things going on. First, there wasn't a lot of data available from satellite sources to really, gauge the scale of this problem.
Mm-hmm.
So it's not immediately clear to me that it's really ramped up recently. I think a lot of the discussion on it also is because now the data are available for people to monitor it.
Mm-hmm.
But also there's other people have written about how there's a shortage of labor in agriculture in rural areas, which is also contributing to farmers using these shortcuts, where they may have previously used mechanized systems to clear the stubble. So it's a combination of various factors that are potentially contributing to the increased visibility, at least, of this problem. So just to give you some photos, you're familiar with it. Here's a photo of Delhi with some Instagram filters. Here's the same area with really, really bad air. AQI can rise up to 600, 800. And people in the US may not be very familiar with it, but because here they close schools when AQI rises to 100. So this is really, really hazardous air. This is Lahore, where I'm from. Here's Lahore on a clear day in April with 37 AQI. Here's Lahore in early January with 496 AQI. So again, the problem is visible. It's increasingly toxic. Millions of people are dying because of it. Everybody's coughing, at least on the streets. How do we think about resolving it? How do we think about managing it? So that's what I address in this paper. So from the bureaucrats' perspective, or the government's perspective, on the one hand, there is increased pressure on them, and they're being monitored to deliver in terms of curbing this problem of crop stubble burning and thereby reducing air pollution. But on the other hand, many of the bureaucrats who are dealing with this problem are in, for example, the agriculture department, and so they have a multi-pronged relationship with the farmers that they're supposed to stop. Not only do they have to get them to stop burning, but they also have to get them to use a particular kind of seeds, particular kind of fertilizer, work with them for agriculture, water use, etc. So they do have a relationship where they can't take a very heavy-handed approach. So there's a lot of variation in the extent to which bureaucrats are actually able to implement some of this. There's a question back here? Yeah.
Yeah, I'm just wondering if you could explain to us a little bit about, so there's laws at the national level and there's laws at the state level, and I'm assuming that the variation in bureaucratic enforcement is coming from those state level laws, but could you just kind of explain how the laws kind of interact with each other and what other frameworks within bureaucrats are trying to implement laws?
So as far as I know, every single state in this area has made crop stubble burning illegal and given bureaucrats the power to arrest farmers who are burning. So and they can put them in jail. They can impose fines. But in practice, what's happening is that, as I'm going to show you in a second, bureaucrats are using a host of carrots and sticks to manage them. And the reason for it is because they have these long-term relationships with farmers. So they can't take a very heavy-handed approach. But at the same time, farmers are also incredibly poor. So it's understandable why they're relying on these technologies to clear the stubble. So it's a very complex problem as a result. But as far as the legal infrastructure is concerned, yeah, it's illegal for them to burn stubble at this point. So just to give you a few quotes, these are from a Washington Post article in 2018. A senior bureaucrat known for his tough approach to polluters, Pannu is leading the anti-burning efforts in Punjab. He has mostly carrots, not sticks at his disposal. For the first time this year, India's central government earmarked money to help farmers buy machinery. So these are things like happy seeders that turn straw into mulch. It has also contributed to a large-scale awareness campaign, complete with songs on social media, television advertisements, and village-by-village meetings, urging farmers to stop burning. The same article goes to talk about various specific bureaucrats. Here's one bureaucrat who visited each of the 182 villages in their territory and kind of like relied on all kinds of things, including, appealing to the children of the farmers, and they talked about, the religious precepts, etc. So all of these are things that bureaucrats are using. There's an article from this year, this crop stubble burning cycle from Haryana, which says that conversations with farmers indicated those in a Haryana district shun stubble burning because of strict vigilance by district administration. So the idea here is that districts, which is the primary unit that I'm going to be focusing on today, do have the power and ability to affect change on the ground. Farmers were afraid of penalties. In our village, at least 2 farmers were fined for stubble fire, so the fear of penalty also discouraged farmers from burning. Then Dr. Karan Chand, the Deputy Director of Kaithal District's Agriculture Department, told News Laundry the district administration had launched had collected 9.10 lakh as penalties from 402 farmers in the district. So there is some evidence that bureaucrats are using some of the legal apparatus at their disposal to actually affect change on the ground. They're able to collect some of these penalties and are able to stop people from burning. But again, the implementation of this has been incredibly inconsistent. So the question we ask in this paper is, under what conditions are administrators going to exert effort to control crop stubble burning? And we're going to hypothesize that administrators take action against burning when the externality from the pollution is going to affect their own constituents, and they're going to allow polluting activities when the externality is going to be borne by somebody who is outside of their constituents, their districts.
Asad,
Yeah.
so I know you're focusing on the bureaucrats, but can you say something about the kind of the village leadership? Like whether there's some attempts to have some social sanctioning rather than kind of more formal sanctioning.
Yeah, so you can imagine that the village leadership have to take an active role in perhaps coordinating, let's say, renting a mechanized device to do that, so that they come up with some way that all the farmers in the village share it. And there are definitely people have written books on this where there are stories where some villages are able to do it very well and others are not. At the same time, these village leadership, including elected leaders, have to deal with the bureaucracy and do some kind of a compromise on that front also. So yeah, the village leaders are important. They're going to be the ones who often the bureaucrats will approach for some kind of solution. But often from the bureaucrats' perspective also, they want to be seen as just. So they want a farmer level intervention from their side also, right? So it's again this complicated relationship where the leaders at the village level definitely have a role to play. Through collective action, they can resolve a lot of these problems where they can sort of maybe spread the costs of renting machinery, or they can approach the district administration to get some machinery. But the number of machines, for example, are way less than the demand. At the same time, many farmers have tried many different technologies and have gone back to burning because that's the cheapest for them. I think the problem here is that at the farmer level, the cost of burning is so low that any other technology is way more costly for them. So that's really the difficulty.
Yeah, that's why I asked about social sanctioning, because from a collective action problem, it's clear that that's for each person that's the dominant strategy, right? Unless there's some sanctioning that could be either from top down or from
So at the village level, you can imagine the externality is again really downwind, not really within the village. So again, that really doesn't align the incentives. It's the classic problem of environmental management. Yeah.
I'm just curious, in your theory, where's the pressure on bureaucrats coming from? Is it coming from above or is it coming from below? Because it's not really clear to me. I'm just following up on Guy's question that there's community mobilization, that we need to hold political elites accountable for pollution. So I was just wondering, how are you thinking about it?
Well, it's both, no? So you can see that politicians are hyper aware of this problem and are trying to resolve it. So they're putting through their cabinets pressure on bureaucrats to perform. and bureaucrats, in their annual reports, these kinds of things actually do enter the calculus. So they do care, as long as they care about their career concerns. And one bureaucrat I interviewed said, I'm going to exert effort where my effort is going to be monitored by other senior bureaucrats, and we're going to have a test of that later on. So bureaucrats do care about their career concerns, and this is entering their calculus over there. You might also imagine that it's coming from bottom up, where cities who are on the receiving end of all the pollution are putting pressure on bureaucrats to do that. So I'm going to show you that the results are similar if you think about how many people instead of how much area is getting polluted within the bureaucrat's own jurisdiction. Yeah.
Can you just give us an estimate of how much it costs to use alternate technology versus the cost of the fund?
Yeah, I don't remember the exact numbers off the top of my head, but I think it's something like 1,000 rupees per hectare, if I remember correctly, to rent one of these happy cedars. I may have the exact number in the paper, but some people have done some estimates of it.
And the fine is like 20,000 or how much is the fine?
That's a good question. I can look it up. I'm not sure about the exact number. I think the main thing is they get locked up so they can also go to jail, which is the other big thing. Yeah.
So, sorry, Sad, which administrator are we thinking of? Is it the DM, the SDM, the SP? Like, who do you have in mind as like someone we should be thinking of as the stereotype of the administrator that your theory is focused on?
Yeah, so I think that's a great question because there's so many departments in the government, and so the work that I've done so far seems to suggest that obviously the key bureaucrat is the district manager, who can be whatever title they have in various states, etc. And then under the district managers are the various departments of the state. You can have the environment department based on the state. You can have the agriculture department. My sense is that in most of these places is the agriculture department, which is the key agent of change, because these are people also. These are departments who also have a high number of agents in rural areas because they have to deal with farmers on a regular basis. So it's really the district manager then putting pressure on the agriculture department and working with them to make things happen at the ground. So for instance, I'll give you an example. The Punjab Secretary of Agriculture, whom I was talking to for a field experiment, was interested in these farm level predictions on who's going to burn. And then they gave me information, or they showed me their dashboard where they have these agents on the ground, who go to talk to farmers for various things. But these are the people who can be sent to a specific farm and be used to exert pressure on farmers to not burn.
And they have arresting powers as well, or the police has to go with them.
So it's going to be the district manager, right, who's going to then work with the police to arrest.
I see.
Okay. Yeah.
Just
They have ability to impose fines though.
Yeah.
Yeah.
Just since we're on this, I thought I'd wait until the later part, but since we're on this topic, would you say that it matters for your theory that this is a bureaucrat-citizen relationship? In other words, they are the ones who are empowered to do this, but if I had a story where everything is being driven by higher level political elites, including, say, the turnover, after which, where there's a transfer that then enables fires to be set, etc. Does it matter for your theory? Do you think your evidence would be consistent, or your even model is consistent with? It could be the bureaucrat who's doing it direct. They are the implementing agent. They could be doing it of their own volition, or at the backing of a higher level politician. Is that an important distinction, or is that kind of not necessarily significant for what you're interested in studying here?
It could be interesting, right? So think of the way the jurisdictions are designed, right? So the politicians sit kind of under the district bureaucrat. So a test that it's not in the paper yet is we study what if the politician is aligned with the state government. So the idea being that they have more access to political resources, and assuming that there are lots of farmers in their constituency, is the bureaucrat able to still take an action or not? And what we find is that the effects attenuate in aligned constituencies.
Okay.
So that kind of suggests that, okay, there might be competing incentives, in other places there might not be. So my sense is that this is more about the bureaucratic side than the political side, but one can think of interactions based on the various jurisdictions that are operative. Okay, so I think it's important to think about how this problem is being managed, because unlike many other environmental problems that we might think of more theoretically, a Gaussian solution here is not possible, or it's very difficult, because not only is it difficult to ascertain who's polluting me, who really is upwind from me, but also when you're sitting in different jurisdictions, in different countries, different states, that problem might be aggravated even more. What we do is we causally identify the strategic behavior of administrators by using changes in wind direction over time and a difference in differences strategy. The idea being that the same location is going to pollute the jurisdiction of the bureaucrat versus the jurisdiction of another bureaucrat. And that variation is going to produce changes in incentives to curb air pollution in that area. I'm going to show you that administrators curb pollution when their jurisdiction gets polluted, and they allow it when other jurisdictions get polluted. We're going to study how administrators' behavior responds to corollaries of externality theory as applied to government. So we're going to show you that changes in fire patterns respond to the cost-benefit calculations of administrators, and capacity constraints from the administrator's point of view also predict where changes are going to take place in terms of where we observe fires. And finally, if there's time, I'll also study public health impacts of this air pollution and try to back out how much of the bureaucratic action is actually contributing to this problem of like increased public health consequences in downwind areas. Yeah.
Would you then say that administrators are purely reactive rather than having an active mandate, which is either punitive or carrot-like?
So that's a research question, right? We don't. I mean, there are two states of the world. One is that bureaucrats are completely overloaded with work,
Right.
and so they would do anything to not have to do anything, right? On the other side, they might be, they might actually utilize information to proactively stop pollution from happening. I'm going to show you that there's evidence for both those stories, and actually the size of the effect is exactly the same, suggesting that like our theories of bureaucrats as being not being proactive might not be correct, at least as far as at least this problem is concerned. I'll skip the literature, but basically we study both inter and intra-jurisdictional issues, which a lot of the literature in the past may not have done. And in the paper, we call this one of the largest public health emergencies in the world. It's just that because the impact of the problem is felt many years down the line, many people aren't really thinking of it as something that's extremely important to stop. So let me tell you a little bit about the data. The data basically for this project comes mostly from satellite images. So there are some trade-offs there. Some trade-offs are as follows, which is on the one hand, you can observe this problem at a really, really large scale. In fact, I'm going to look at districts for this entire area over here. But on the other hand, of course, you don't exactly get to observe the interaction between the bureaucrat and the farmer. So that's a trade-off between sort of micro and more macro level studies that everybody faces. I'm going to try to convince you that patterns in the data actually are responsive to many of the hypotheses you might have on how bureaucrats are acting, and I would love to hear your thoughts on that. So I use daily fire data and aggregate it up to the month level from various satellites. I use monthly wind patterns. The idea here is that these wind patterns will allow me to proxy for bureaucrats' beliefs on which way the wind is going to flow in a given month. So the idea here is, let's take November 2022. I'm going to proxy for the bureaucrats' belief on where the wind is coming from in November 22, based on all the Novembers from 2012 to 2022. Okay, so that it's going to be a rolling average at the decade level.
Just curious, in any of the bureaucrats you talked to, did you ever quiz them like, hey, which way is the wind blowing?
I mean, I think, don't we know where the wind is blowing?
I don't know which way is north or south, but I'm not a bureaucrat, so I would be a bureaucrat. But people say go west to meet me to this coffee shop. I don't know what that is, but no. But seriously, I just
So people in agriculture department know which way the wind is blowing, when the rain is going to happen. They're extremely attuned to these kinds of weather-related phenomena. So I think it's a good proxy, but in reality, the 10-year rolling average is very similar to actual wind patterns, as you might imagine. There are a few anomalies here or there, and one of the reasons for doing it at the month level is exactly this: that people might have bad guesses on which way the wind is going to blow today, but in general for this month they're going to have pretty good guesses. Yeah.
How dispersed is two questions. One, how dispersed are wind patterns across regions? I have no idea. And then two, you might get to this, but are the bureaucrats, have they been stationed in the same location for an extended period of time so that you would be able to approximate this?
Yeah, I'm going to show you both. Both are coming up in a few slides. So just hold on for 1 second. Yeah.
Just a quick question. How far do these particles travel in the sense that if you're looking at like wind patterns and wind direction, where's the limit to that?
Yeah, so I'll show you also that when we go to the health effects, but based on the speed of the wind, the direction of the wind, they can go from, like, let's say this fire can pollute all the way till here. But it can also pollute only till here, so it really depends on the specific wind patterns. And I'll have a meteorological model at the end to actually predict the trajectory of the fires when we calculate the health effects. Okay, I also have crop production data from 2004 and 6, which is sort of a pre-period to our analysis. This will allow me to classify what areas grow rice and which ones do not. I'm going to focus on the high air pollution areas, which are going to be these states over here, as well as Punjab and Pakistan. So we're going to really focus on these areas and try to study how this phenomena plays out in practice. So in these places, which are marked in green over here, and the blue lines are all of the districts that are going to be in my sample, what I'm going to do is, for each district, I'm going to divide it up into these small 5 kilometer square grid cells. And within each grid cells, I'm going to study how changes in wind pattern affect the number of fires that are happening in these grid cells. So we have a total of about 17 million observations in the data focusing on this area.
And like, what proportion of these would be district boundaries? Like
The district boundaries are in blue.
Sorry, your unit of analyses, like, are a lot of them like boundary cases where they're between two districts? 1 5 square
No, so
kilometer.
you can see the little boxes here.
Yeah.
Each of them is a 5 kilometer square area.
Right.
So there are very few, there are hardly any boundary cases.
Okay.
Most of them are going to be on the interior. And the reason for going so fine is exactly to limit those kinds of attribution errors. Okay. Okay, so let's move on to the first part of the results, which is administrators reduce pollution when their own jurisdiction is affected. So what is the estimation strategy? Well, I want to establish if a grid cell, which is that 5 kilometer square small box that I showed you, is a source of pollution for the jurisdiction of the bureaucrat or their neighbor's jurisdiction. So let's take the example of this district over here, and each of these boxes represent the 5 kilometer square grid. Imagine if the wind is blowing from the northeast like this, then a fire in this grid cell is going to pollute all of the areas in red. Okay. Similarly, if a fire in this grid over here is going to only pollute this area in red. So that's going to create this spatial variation in the data, which is, in the first case, a lot of my own district as the bureaucrat is going to get polluted, whereas if I allow a fire in this area, then a small area within my district is going to get polluted. Now imagine if the wind shifts now for the same location in my own district, I'm going to now, my own district is now going to get polluted. So you can see that this creates this temporal variation. So we're going to use both the spatial variation, which is what is the specific location within the district, and I'm also going to use this temporal variation to sort of study how shifts in wind pattern create incentives for me to go and stop fires in certain locations. So for each month in our data, we define each grid as treated if the area of the district downwind from the grid is larger than the area of the district that's upwind from the grid. The idea being that it's treated when the bureaucrat should really care about stopping pollution in that area, and it's not treated when a large part of the area is actually upwind from me versus downwind. Yeah.
Sorry, I'm trying to wrap my head around this. Is there a fire burning season where you would see fires all over the place at the same time, so that spatially, like, everything would be covered in smoke?
Right, so fire burning seasons are mostly in October and November and early parts of December, based on where you are in the subcontinent. So yeah, you'll see more fires over there, and I'll show you the effects are much larger during the fire burning season versus other seasons. Yeah.
Just to follow, I think the question was like, aren't there fires in every single field? Like how, like you're like in these diagrams, you're like isolating one fire and showing us like, what's happening with the wind, but like in practice, aren't there fires everywhere?
I'm not sure if I follow the question, but yeah, so each grid cell has the potential to have a fire in a given month of the year, and so that's the spatial variation, because if there's a fire in one part versus another part, it's going to, the strategic calculation from the bureaucrat's perspective is going to be different based on how much of the area is downwind. Now there's going to be some temporal variation because not everybody is literally burning at the same time. They will burn when they harvest their rice crop and before they put in their wheat crop. So that's going to create spatial variation in the data. And we're going to study when they actually, we're going to study how many fires actually happen, the idea being how many farmers choose to burn.
But I think
in
their
that area.
question is, which I think your answer would be that if, let's say there were 20 fires right now in this
Yeah.
area,
Yeah.
it would basically still be just the rule of the spatial location.
Exactly.
So they would either count like 10 would be treated and 10 would not if the 10 that were treated had the majority of the district downwind versus up. So even if they were all simultaneous, you could still get variation in the treatment.
That's right.
Right? That's how you-
and the fires are the outcome. They're not on the right-hand side.
Right.
So
That's right.
the right-hand side is a location within my own district. And the idea is that do I go and put effort to prevent fires from happening in that area? And the number of fires might differ based on my strategic incentive. Yes.
What they're trying to get at though is there a spatial lag dependent variable or something like that in the models that would be on the.
Right. I'm going to show you an event study to show that that's not really a concern. Okay, so for each month we define each grid as treated if the area downwind is larger than the area upwind, and in each district and period treated grids can shift their treatment status based on the direction of the wind. We use a 10-year rolling average of wind direction in that month to proxy for bureaucratic beliefs, as I said. So just to give you a sense of what the treatment variation looks like, I don't know who has access to the computer, but if you can click on this button, that would be useful.
Oh. No, that's on the home page.
It's also.
It's okay. Oh, it's also on 7? Oh.
Sorry.
No, it's okay.
No.
Is it
No,
right
the one on the left. No. Just the one with the triangle on the right side. Yeah. Okay, so this figure is going to show you the variation in the data set, which is areas in blue I think are treated and the areas in white are controlled. So you can see that with changes in wind direction, the same location in the district sometimes is treated, sometimes is controlled. And you can see that there is variation like on the district boundaries themselves, where two places that are right next to each other, one of them happens to be controlled because the bureaucrat is not going to get affected in their own district, and the other happens to be treated because the other bureaucrat really cares about that place. Okay, so this is the variation that I'm going to use in the data.
In your like sense of the data, are there places that are never treated or always treated?
Yeah, so in the event study, I'm going to create a stack where I'm going to control places that just move into treatment,
Yeah.
versus places that have stayed as controls in the event study period.
And just to confirm, you don't take into consideration the strength of the wind or the fires, right?
Well, the fires are an outcome, so we're not going to put them on the right hand side, but the wind speed and direction are going to be controlled in my regression. Okay, so the estimation strategy is pretty simple. I'm going to count the number of fires in a grid cell in a given month, and I'm going to estimate what happens when the grid is treated, which is that the bureaucrat's own area is going to get polluted. And then I'm going to have a bunch of fixed effects, including fixed effects for the specific grid. So it's going to be variation within the grid cell over time. And I'm also going to put in fixed effects for district by month. The idea here is that the district as a whole might have some month-specific factors. For example, what direction wind is blowing in that month. So this is going to absorb all of that variation. We're going to only identify off of changes within the district in that given month. And there are controls for wind speed and direction. I'm going to cluster standard errors by grid and district by month here. So this is the event study graph, which is the main result in the paper. Basically what we see is at month 0 is when a grid moved from being in a control condition to being in the treated condition. As soon as it becomes treated, the probability that the number of fires that are happening in that grid decrease by about between 10 and 20% based on the specification. And the idea here is again that this is when my own district is going to get polluted. That's when I'm going to put in some effort potentially to reduce the number of fires, and that's what we see in the data. Critically, we don't see much happening before the shift. So this was the problem, if there was a problem of like specific time trends were driving the results. Yeah.
Could it be that like the farmers themselves are internalizing the fact that they could like affect more of the...
Totally, yeah. So you can imagine two stories. One, the bureaucrat actually going and stopping them from burning. The other is farmers anticipating that the bureaucrat's going to come and find me, so I'm just going to not do it. So both of those are consistent with the results.
But it also could be consistent with like, I care more about people in my district, right? So if I know that like I'm gonna be polluting on my district versus the neighboring district, I might be like, maybe I'll wait with putting this fire.
So district identity isn't really a thing.
I don't know
Yeah,
anything
yeah.
about it.
You might say, okay, provincial identity or state identity could be it. The district identity is not really a thing, but you can actually estimate. I think what farmers, a really pro-social farmer, and I don't think they're going to be that, but a really pro-social farmer might say that I'm going to think of all of the people downwind from me, and we can estimate that. We haven't done that yet, which is basically to say that remove the district boundaries completely and estimate the same thing for the entire sample. One can do that to see what percent of the effect might be driven by just pro-sociality of the farmers. Yeah, but you'll see that there are going to be many more results that are going to be completely consistent with bureaucrats exerting a lot of effort in the data. Yeah.
Sorry, I'm still having a hard time understanding the treatment, so I just want to clarify. So the treatment is the shift in wind direction?
No, the treatment is if a particular. The treatment is if a particular grid, if the area in the district that is downwind from a grid is larger than the area in the district that is upwind from the grid.
Okay, and how closely does that map onto like AQI? Like I don't know if you did that, but I'm just curious about like what is the AQI level in like a treatment versus like a control grid?
Well, nobody knows the answer because AQI is never measured that precisely. In fact, in the Pakistani Punjab at least, there are hardly any air quality monitors outside of Lahore. And even there, the Environmental Protection Agency, I forget the exact name for it, wants the US government to remove the sensor in the consulate. So, because they don't want people to know. So we don't know. But also, this is going to ramp up as you go in the season. So I think one benefit of this study is that we can study the actual polluting behavior instead of the pollution itself. So we can actually isolate the specific action that is contributing to the overall problem of pollution that many previous studies are unable to do so. Yeah.
Saad, could you say, like, looking at these results, why you think this is a story of strategic bureaucrats? There are 15 fires in my district. Some proportion of them are the ones that I should be worried about, but I only douse 2 of those fires. So what degree of strategic thinking are you investing your actor in, or could it be just that those 2 other altruistic people who stopped doing it, as like a previous explanation was? Like, why is it about bureaucrats given the evidence
that... Well, first of all, it's the jurisdiction that's determining whether a specific grade is treated or not is based on the jurisdiction of the bureaucrat.
Yeah.
Unless you have a story that farmers somehow really care about the district boundary versus not, that story doesn't really conform. And I'll show you in a second that the results are going to go in opposite directions based on whether more of my jurisdiction gets polluted or less. So I'm going to show you a bunch of new other results that are going to show you how, as the incentive to curb this increases, the fire patterns respond precisely with bureaucratic incentives.
The only reason I say this is because a lot of Hindi newspapers, for example, which are read, have district editions. So there is a reading public that is organized around the district. It may not, district identity may not be a thing, but it may be a coherent body of information for a lot of people to form opinions about their local environment.
Okay, and how would that matter?
So some people, some 1 odd farmer or 2 odd farmers which are showing up as a result, may be people who actually do care about the fact that their district is less or more polluted.
Well, it's like 20% of the effect. It's 20% fewer fires. It's not 1 or 2 odd farmers. It's a large size of. In fact, I think the next result. Hold on for 1 second. Okay. So this is just the table version of the same result. But the next result, and we do a whole bunch of robustness, including with actual population instead of area, and we find the same result, and we do a bunch of other stuff. It's always the same. But this is what I want to show you, which is you can do the same estimate, but now you can do an interaction with rice producing areas, and you can do a further interaction with harvest months of rice, and you can see that the effect is actually about 40% larger than the effect that you see in the entire sample. Again, the idea being that these are the areas and the times of the year when you should really see this ratcheting up of the total number of fires. That's also when you see the largest strategic action by the bureaucrats.
I guess the question is, so this is a lot about like the social mechanism, but I'm still wondering if this could be consistent with a model where it's not the bureaucrat is just the implementing agent, perhaps, but local politicians just saying that we know this is happening, our constituency is going to get most affected, our political incentive, our population is the most, most affected, this is the time of year they're most affected. So we are going to either directly or pressure the bureaucrat to put out these fires in both as the source of information and as the kind of source of leverage.
But I think the story has to be a lot more precise than that.
Okay.
It can't just be that the politicians are pro-social and care about their own constituency.
It's not pro-social, I mean, they're politicians. So they may say that we have an electoral incentive to not have most of our district polluted.
Well, they're not getting elected by the district, right? They're getting elected by the village or the the MLA jurisdiction, which is so. What I'm trying to say is that the story has to correspond precisely with the
their
boundaries of the
constituency.
district,
Okay.
and not with their constituency. So that's the key, because the treatment is defined in relation to the polygon
Right.
boundaries.
Right.
So that I think is the key. So an alternative story has to account for that whole polygon, not just the specific location that the politician is getting elected from.
Okay, that's untested though. I mean, you could imagine that this would be, maybe that's what you're looking at, but if we were to find that this result held up within those polygons, then that would be consistent with them pooling their effort.
You can
to
do the
pressure
same.
area.
You can do the same exercise for political areas, right?
Right.
And you could find an effect that is similar. And in which case, my conclusion would be that politicians also care about their jurisdiction, and they perhaps put pressure on bureaucrats similarly, and that gets translated into action. But that story in itself is not enough to explain this result, because it has to be a lot more. The strategic calculation has to do with the bureaucratic boundaries, not with the politician boundaries.
Right. I get that from the point of view of the setup, but these are not completely unrelated concepts, right? Like political constituencies are embedded within and there's a pooling effect, and this is the relevant bureaucrat to pressure.
Yeah.
So I get that from a methodological point of view, but it's not that these are completely unlinked. That there isn't a way in which those could aggregate into the effect that you're observing at the district level.
Totally, yeah. You might imagine that the district headquarters, which is where you have most of the population, is in the downwind area. So they bear the brunt of all the farm burning upwind from them during fire season. You can totally imagine them calling up the MLA and asking the MLA to call the bureaucrat to do an action.
Right.
But that the bureaucrat is still going to act within their own jurisdiction. One mechanism might be citizens putting pressure on the bureaucrat, but I think the point of this paper is to say that the where you observe the effect is based on the bureaucratic boundary. A mechanism could be political.
Okay.
Or you could just redo the analysis with political boundaries, right?
You could, but I think that would be a very different paper, right? So there the question is, are politicians caring about the constituents that are within their jurisdictions?
Yes.
And if yes, then they're going to call somebody to affect change on the ground within their own jurisdiction. Right? The story, you could test it. I think the story is a little more roundabout than testing with bureaucrats directly.
I guess just building on Tariq's question, if that evidence was no effect, then the bureaucratic story is strong. If that evidence is that there is political boundaries do make a difference, then there's some interaction between politician and bureaucrats that might be driving your conclusions, right?
Well, the interaction would boost the conclusions.
Yeah,
they wouldn't dismiss them.
Yeah, no, absolutely.
Yeah, because even if there is a politician effect, it has to operate through the bureaucracy.
Through the bureaucrat.
Yeah,
That's what I'm
of course.
saying.
Yeah, absolutely.
Yeah. Thanks.
So just to confirm on the result that we just saw before this, the unit of analysis is still a 5 kilometers square.
That's right.
So we're saying that the number of fires in that square increased based on the effect that area was having on the rest of the district.
That's right.
So, I think this ties back to like the questions we just had before, but if we're saying that the reason is that there is a bureaucrat who has a jurisdiction who's like fresh in making this happen, shouldn't we see whether this holds if we're like looking at the district level? Like, do the number of fires in the district decrease based on like the effect, the change in wind pattern in the district?
Yeah, I think that's an empirical question. And I'll show you in a second that actually there might be reasons to expect that the total number of fires won't really change, because they're going to allow fires in one area and remove fires from the other.
Oh, so you're saying that there will still be a spatial shift within the district, but not like a reduction in number?
Yeah, I'm saying that that's a question to be explored. It's not obvious just from this result that I've shown you what is happening to the total number of fires.
But then if we tie this back to like the debate we just had, which is that so just my takeaway from this figure should just be that the number of fires decrease, but how should I like look at how the story is playing out from here?
Well, the takeaway should be that the number of fires decreased by 20% in areas of a district that are going to pollute that district itself.
That they're optimizing everything.
They're optimizing effort, which is to show that bureaucrats can affect change in polluting behavior when it's strategically incentivized for them to do it. And it has a big effect on the outcomes. Okay.
Questions.
Yeah.
I was reading some newspaper reports way back that probably Haryana is more successful containing this than Punjab. Then does that add to Tariq's point that that there's a difference because of political parties or a more top-down mechanism which is acting on bureaucrats?
Well, the effects are largest in Haryana,
Okay.
which is to say that bureaucrats are the most strategic in Haryana than other places, but the effect exists in all of the states in the sample. But it's like a heterogeneous exercise. There can be many other factors driving it.
Yeah.
Okay, the second part of the paper looks at how these patterns change in response to the cost-benefit calculations of bureaucrats. So because of time, I'm going to move through these a little fast. Why read the title anymore to remind myself?
The menu. Effort is proportional.
Oh yeah, okay. So now what we do, I was trying to remind myself. So now what we do is we're going to say, okay, let's think about it from the bureaucrat's perspective. Their incentive to curb or allow fires are going to change based on how much of their own district gets polluted. To proxy for this, what I'm going to do is I'm going to take each of those 5 kilometer square areas, and I'm going to code whether that area is close to a border or it's far from a border. Okay, Q1 is going to be that quintile of the district that's closest to a border, and Q5 is going to be the one that's most far away from the border. Now, because of changes in wind direction, areas that are closest to a border can sometimes be close to an upwind border. So if wind is coming from here, they're close to an upwind border. But if the wind shifts to this direction, they end up being close to a downwind border. Okay, and this is going to produce even more variation in the strategic incentives of the bureaucrats, where over here they're going to be most incentivized to curb pollution because these areas are going to pollute even more of their area, whereas over here they're going to be most incentivized to allow pollution because all of the pollution is going to basically go into the neighboring jurisdiction. Okay, so that's kind of what we're going to do. We're going to decompose the effect by how close you are to a border and whether that same border happens to be a downwind border or an upwind border based on which way wind is blowing in that month. So this isn't working anymore.
You can actually, yeah.
Okay.
Oh, sorry.
Okay, now it's working. So this is the result. Basically, the way to interpret this is these are the areas over here that are farthest from a border. We're going to baseline everything from this. These are the areas that are closest to a border. So the same area can sometimes be close to an upwind border, sometimes to a downwind border. And relative to areas that are most far away, as the areas become closer and closer to a downwind border, where I can offload the externality to my neighbor, the amount of fires actually increase. And as the same areas get closer and closer to an upwind border, the number of fires decrease because I am going to bear the brunt of the pollution. Now, this is the question that was asked earlier, which is, are bureaucrats actually exerting effort to curb pollution or allow pollution? And in this case, you can see that the estimate actually is very similar in both directions. And this wasn't very obvious going into it because, the conventional theory would have you believe that they'd rather not do anything than do anything. But in this case, we have evidence to suggest that they're actually, on both ends, the effect seems to be very similar. Yeah.
Just a quick question. In terms of second order effects, for example, like my neighboring district, I know that the wind is going to blow in my direction and I'm going to get that pollution directly. And I still care about my constituency. So won't my strategic incentives update, and am I doing something to curb that inflow? Am I talking to the bureaucrat next door? What am I doing in that scenario? Because in your model, I think those incentives still remain. So I wonder, could you capture those second order effects or not? Or do you have any expectations?
Yeah, so I'm going to show you a result that as coordination fails, the strategic effect worsens. And the effect is up to 5 times larger, which is coming up in a second.
So
Yeah.
this is akin to redefining your treatment as a continuous, right? That's a You would have got probably something similar.
Well, it's a little different, no, because now it's not just whether the specific grid is polluting my district or not. It's also saying that, you know, how much of my district is getting polluted.
No, I know, but I totally get that. I'm just saying you could have like defined the treatment not as binary, but continuous, right? Like,
and we do,
And so I'm saying this would be akin to the similar analysis, right? And the idea
but that wouldn't allow you to study this idea that the same location flips when the wind shifts. But yeah, we've done the continuous version. It's similar. But I think, so the key insight here is really this flipping of it's literally the same location because we have grid fixed effects that sometimes have lower pollution versus other times when they have higher pollution. Okay, so we also show that as the problem increases, the strategic effect goes larger, where the dotted lines are what I showed you earlier, and the solid lines are what happens when the rice producing area within the district increases by 1 standard deviation. Again, the idea is as the bureaucrat faces more problems in terms of stopping the total amount of crop stubble burning, the strategic interaction effects that you see in the data increase even more. And these are significantly different from each other also, you can test them directly. Okay, this is the coordination story. So what we do next is we say, okay, what happens on the India-Pakistan border? The idea being that, you know, now I have very limited ability to coordinate with the bureaucrat who's next door to me. And basically what we see now is that the effect, this is what I showed you earlier, and this is the effect on the India-Pakistan border, and it's about 5 times as large as what you see in the rest of the sample. And our interpretation of this is that bureaucrats in these districts which are on the border have very limited ability to coordinate with any bureaucrats who are on the other side, and that might be producing some of the effects that we see in the data. What we also show is that the pollution responds to bureaucrats' own capacity to observe it. What we find is that the effects primarily come from areas that are close to main roads. Again, the idea being, this is from a conversation with the bureaucrat who said that for me, it's going to be important that, you know, my supervisors are not able to see the fires that are happening much far away. So I'm going to try to first exert effort on places that are, you know, that are observable by other people who might sanction me. We also show that we compile a new data set of district level bureaucrat turnover for this entire area, which was a huge exercise. And we basically show that in the 2 or 3 months after a bureaucrat turns over, the effect actually disappears, and then after that they presumably learn about these strategic calculus, and then the effect resumes back to normal.
So on the incentive story, is there a way to control for the percent of the constituency that is made up from agricultural income using census data? Because the incentive would be stronger theoretically to not punish where most of the voting bloc is full of farmers, whereas it would be less so. There would be a greater incentive to punish in areas where the voting bloc is non-agricultural.
So I guess one way in which we do it is through the rice producing area, right? The idea being that as the amount of rice that's grown in the district increases, the strategic effects that you observe in the data also increase. But the bureaucrats are not elected, right? So it's a little unclear how specifically they should be responding to those calculations. I guess that's where you can do some of these interaction effects with the elected politicians who, if they're elected primarily from a constituency of farmers, they're going to put pressure on the bureaucrat to not fine or sanction the farmers. Whereas if they're elected from an urban area, then maybe they have an incentive to actually push the bureaucrat to make even more actions because they're bearing the brunt of the pollution. So those are things that we can test, but we haven't done yet.
So in theory, just to clarify, the incentive of the bureaucrat to adhere to this law to punish is strictly coming from the desire to adhere to the law and not from political or other pressures.
Well, we can't observe. It can be a combination of all of those things in the data right now. So the point of this paper is to show that the effect exists. You know, we can do further work to sort of decompose what is the source of that effect. The other interesting thing that we see is there are 2 fire seasons actually that you might not be familiar with. The other fire season happens in May, which is the number of fires are about the same as the rice fires that you observe in October and November. And what we but in the May fires, which is when you harvest the wheat crop, don't produce pollution that is visible because of other atmospheric conditions. And what we see is that the same effect actually does not hold during the May times, during the May fire season versus the October fire season. One interpretation of this is that bureaucrats will only care about stopping polluting behavior when there is a general when the problem is generally very visible. This is completely congruent with what you see in government ministries, which is because they're so overwhelmed with work, they're going to only really exert effort when there's a lot of pressure around it, and that pressure really starts in the October-November window. And the one way to think about this is that many people aren't even aware that the number of fires are there's so much crop stubble burning even in the May period. Our entire focus happens to be just when it's visible, which is in October and November. Okay, just to summarize, what have I shown you so far? I've shown you that administrators reduce pollution when their own jurisdiction is affected, and that the polluting behavior responds to the strategic incentives of the bureaucrats. The effort they exert is proportional to the damage experienced by the constituents, the idea being that as the strategic incentive increases, the behavior is responding as theory would predict. The strategic reduction matters more when pollution is a larger problem, when there's more rice producing areas, and strategic inaction is larger in the presence of high coordination costs as proxied by the India-Pakistan border test. Pollution reduction further responds to administrators' constraints. It's when they can actually see the fires. It's based on administrative experience as proxied by the turnover, and based on citizen awareness, perhaps through the May fire test versus the October-November fire test. Okay, in the last 5 minutes, I hope.
Yeah, you've been getting questions through also, that's fine.
Okay, so I'm going to spend a few minutes just to try to estimate the impact of crop stubble burning on health, and then I'll do some back of the envelope calculations to sort of think about how much of the strategic action that bureaucrats are taking, what impacts that has on health outcomes. Now, it's not straightforward to estimate health effects because many of the previous estimates, what they've done is they've tried to look at these satellite images of AQI, which are all interpolated, and trying to estimate how as air pollution changes based on these AQI estimates, how does that affect health outcomes. I believe have a more direct test of how stubble burning is contributing to public health issues. So what we do is we first get DHS data on child mortality from India and from Pakistan for these two waves where we have these GPS coordinates that allow us to study health outcomes in a specific location. We get about 179,000 births across 28,000 DHS clusters over 7 years. This is because in each of these DHS surveys, they're going to interview mothers and ask them about pregnancies that happened in the last 5 years, along with the date of birth, etc. So that allows us to create these panels over a 7-year period. So what we do is we make a pregnancy level database, which is how much, and the idea here is that how much of the pregnancy was affected by air pollution shocks, how much air pollution shocks happened in utero for the eventual birth of the child over the 9-month period before the actual birth. To assess this, the problem of course is like, how do you attribute a specific crop burning action to how much pollution was actually experienced by the mother? So that's the empirical challenge that we try to solve. And the way we do this is to use what's called this a high split model. This is a model that you see on the news channel all the time when the weather persons are telling you which way the dust storm is going to take the dust over the next day or so. So this model, what it does is it computes how the trajectories for air parcels based on a lot of the weather data that you feed into it. So just to give you an example, each of the polygons in this area represent a DHS cluster. So this is the level at which the data are available. And if there's a fire over here, it's going to track, based on the patterns for that day, it's going to go over this little area. So you can zoom in and you can study that a fire over here is going to, the particles from it, so the pollution from it are going to travel this area over the next 1 day. Okay, so you can do this for every single fire in the data set. These are all the fires in 1 month of our data. And so you can see that some fires, go really far away, others don't go as far based on how the wind is actually going to, temperature, etc. Other factors are going to sort of matter in terms of how far the air pollution actually travels. With this, what we can do is we can assign each of the fires to the in utero exposure for every pregnancy in the data. That's going to allow us to get a measure of how much air pollution was actually experienced by mothers when they were pregnant. So then what we do is we estimate a model where we study child and infant mortality, where child mortality is the number of children who die within the first 5 years of birth. and infant mortality is the number of children who die within the first year of birth out of 1,000 births. That's the official model. On the right hand side, we put how many fires were actually attributed to that specific birth, and we control for the month of birth fixed effect. So looking at only birth or only variation that happens in a given month of the year. We also put in DHS cluster fixed effect. Again, the idea here is that within the cluster, within that small location that I showed you, mothers are pregnant at various points in time. So there's variation in like when the child is actually born over time within that location. And then we also put in mother fixed effects. And the idea here is that in our data, many mothers are pregnant more than one time. And so their pregnancy receives different shocks of air pollution based on when they were pregnant, what time of the year they were pregnant. So that's going to allow us to study within mother, so across birth changes in mortality outcomes. And so basically what we find is that first we look at any fire. The idea here is that you're looking at sort of areas that are kind of marginal to the initial area of analysis, because there the pollution is very high. So most of the variation in actual lived experience of air pollution is going to come from areas that are not really in these crop stubble burning areas. So any fire increases the probability that the child dies within the first 5 years. All of these are, so these are 16 additional deaths out of 1,000 births. And then you have the log of fires. And basically what you see in the last model, which is I think the most convincing, that fires move the average mortality from sort of Namibia, Senegal levels, which are about 39 deaths per 1,000, to Mozambique, Mauritania levels, which are about 68 deaths per 1,000. It's a huge effect on child mortality as a result of air pollution. And I think the nice thing about our model is that we can actually attribute specific fires to specific pregnancies, which previous work has been unable to do so. And so there is this large effect. How should we think about this? Well, I think the first thing to note is that when we look at this any fire result, it's not the case that it's 0 fires versus 1 fire. It's actually 0 fires versus a large number of fires. So people who live in these areas are getting all of these fires from stubble burning, because farmers live next to each other, and rice producing areas are obviously spatially correlated. You're going to get a huge shock of fire-induced air pollution if you happen to be in the path of that air parcel. Okay, so then just to wrap up, what we do is we say, okay, let's do some back of the envelope calculations. How much is the strategic action of the bureaucrat, mattering in terms of these public health outcomes? So we say, okay, downwind grids receive, let's say, about 14.5% additional fires per month. The idea here is this is where this is the area within the district that's receiving the fires from the upwind part. So just looking at within district calculus for now, a 1% increase in fires over a 9-month of the pregnancy raises child mortality by about 1 in 1,000 children. This is like the most conservative estimate from our table. Then, so what that means is that the overall increase in child mortality attributed to strategic administrators' behavior is about 15 additional deaths, or another way to think about it is 15 fewer deaths in 1,000 if it were the case that administrators behaved everywhere in their district the way they behaved in the upwind parts of their district. Okay, so if they did the same strategic action in the downwind parts as the upwind part, about 15 fewer deaths per 1,000 would happen as a result of that, based on this back of the envelope calculation. Okay.
Just to be clear on that, it's that if they did more effort, basically, if they matched, not that they behaved differently.
That's right. So if they put in more effort, the same amount of effort that they were putting in the upwind part, and did the same in the downwind part, did the same in the downwind part, then the total number of deaths would decrease by 15 in 1,000.
But they might be putting maximum effort, they just don't have the capacity. Right?
That's right.
All the burns, everyone is burning at the same time. It's very rational to go to the place that pollutes all of your might. So we talked about it. I'm not comfortable with the kind of the
totally, yeah. So
because it could be that they're putting maximum effort.
Yeah. So that's why it's called back of the envelope. It's like a linear extrapolation. So I guess the question for policymakers is to think about, what this paper has demonstrated is that bureaucrats can take action, okay, and their action can produce changes in actual outcomes. that will have these public health impacts. Now, if the bureaucrats are completely overburdened with a lot of work, so this is the only effort that they can produce, then the policy question is how to create slack in the work that they're doing. And I agree with you 100% that this is a complete like linear extension of the result that we've seen. And so this is the max effect that you can estimate. 15 deaths is about, it's like a huge effect based on, it's going to cut the number by half. Yeah. So this is sort of the upper bound of what is in the possible, what is possible. But it is. I definitely take this with the. I definitely take this that the bureaucrats are overwhelmed, so we should think about how to create more slack in the amount of work that they have.
We should move to questions now, yeah.
And can we start with Zoom since they've not had an opportunity?
Sure.
So,
Go ahead.
So there are two questions. First one is from Nikit Agarwal, who is a fourth-year PhD candidate in socio-cultural anthropology at UCLA, and he is studying stubble burning in Haryana. His question is about methodology. So he asked, along with data analysis, did you do some grounded work on the issue of stubble burning? If yes, what do farmers and district-level bureaucrats themselves think about your findings? Since his method, the student's method is completely different, maybe that is the reason why my observations are in stark contrast to yours. For instance, I have worked with bureaucracy closely, attended meetings, hung out with agricultural officers from district head to below, and never saw anyone concerned with the wind direction at all. However, I have seen farmers concerned about it since it is their eyes that burn first and foremost while burning the stubble.
That's a great question, and I think so. One thing that I want to do is I want to decompose this question of how much are farmers caring about their own community. So I think the earlier questions were about whether farmers are pro-social in the sense of sending pollution to downwind areas. But I think there is another argument to be made, which is some of the farmers might actually, when they burn the fire, the air pollution goes to their own village instead of other villages. And I think we can answer that question with some assumptions. Haven't done that yet, but we can totally test it and decompose how much of this effect is based on farmers' self-preservation versus the bureaucrats' own preservation. But at the same time, I think the question is this is what I was trying to say at the earlier about various methods. I think we definitely need both a strong qualitative component to sort of think about this versus also a more macro study like this, because you see a pattern in the data that's 20%, 15 to 20% fewer fires as a result of these jurisdictional considerations. Then the question is to think about, okay, if they're not thinking specifically about wind, how are they still strategically allocating their effort? And I think there is, at least the data is consistent with the idea that bureaucrats are strategically doing it. Then the question is, if not wind, then how are they thinking about this? And I haven't done qualitative work on this, and I would love to do that.
There's one more question I want to quickly ask from the audience. This is Komal Preet Kaur, and she asked a series of questions. I think I'm just gonna. So one is, what do farmers being a vote bank affect administration's effort in curbing polluting behavior? And she's particularly interested in knowing if bureaucrats' residents fall in a grid that you're looking at, how does that affect the polluting behavior?
Yeah, so that's great because the second one is also on the list. Everything in this paper, by the way, takes like forever to run on the lister. So we think of an idea and then a month later we might see the results after implementing it. So the second one is on our list of things to do, which is what if the bureaucrat's own residence is getting the brunt of the pollution, how much of the effect is because of that. It's on the list of things to do and we haven't really done much, unfortunately, with it yet. The other question was about the politics of it. Again, that's something that's not the focus of this paper, but can definitely be an extension for future work.
I had a question about there are a set of people in this story, right, that are just getting totally screwed, right? Like there's a set of people along borders, right, who always have, who if it's blowing their way, basically like just have to accept a bunch of pollution, and then if it's blowing the other way, have to stop polluting themselves, which it sounds like is kind of counter to their individual interests, right? So is there any evidence of like, are they also further from the bureaucrat? Like, is there some reason that like a bureaucrat might also care less about people along these borders? Does that make sense?
Yeah, so I think that's an important question, and the general belief is that places that are on the periphery of districts receive less attention from bureaucrats. I think all of the work that I've done suggests that that's not really anymore the case in, you can look at, for example, night lights and changes in distance to the district headquarters in India, you don't really see any effects. So that really tells me that bureaucrats have, at least in the district level, have, it's very functional state compared to many other parts of the world. So they really are able to observe many different places within their own jurisdictions, a lot more than many other parts of the world. But at the same time, yeah, it's true that some farmers are, some communities are bearing a lot of the brunt of this. And I think the problem remains that these people have bigger fish to fry. They're exceptionally poor communities in many places. Air pollution often is like, the third order concern for them, where they really need to get on with their lives and put the next crop in, etc. So I think it's a matter of like politicians or bureaucrats thinking carefully about like what are the externalities of this problem and how we might want to take a more systematic approach instead of relying on these individual level decisions.
So one question I had was that, this is incredible work and it's really, really thought-provoking, but one thought I had is like, is one of the implications that kind of cheap bureaucratic action to help solve this problem is going to have to be largely coercive. And so what we're going to, there are ways to get around this problem by kind of helping farmers not need to set fires, and then there are ways of just cracking down on farmers and putting them in jail if they set fires. And do you worry, or have your conversations in any way led you to believe that one option would be more likely than the other, that the policy implication of this, while you are also illuminating kind of low-hanging fruit, that there's even lower-hanging fruit potentially that might actually be even more detrimental to farmer lives?
Well, I think first I want to point out that, the India-Pakistan border results show that there is incredible scope for coordination.
Right.
In the rest of the sample, the effects are much smaller than that border. So that shows, okay, that some things are working. It's just that the enormity of the problem is just completely outweighs some of these other issues. But there is research to show that it doesn't have to be sticks. There's a new experiment in 2 districts, I forget if it's Punjab or Haryana, by Rohini Pandey, Kelsey, Jag, and other co-authors, which shows that actually if you pay farmers upfront before the burning seasons begins, I think it's like 800 rupees per hectare or something, you can reduce the incidence of fire by about 8%. So even paying them is not going to guarantee 100% response rate, but it gets you at least part of the way there. So I think what I'm trying to suggest is that, you think about this paper where you have a bureaucracy or a bureaucratic setup that already exists, so thinking carefully about their incentives, perhaps matching them with some kind of cash payments, making happy seeders or other kinds of technologies available in an accessible way for farmers. You'd have to take all of these actions at the same time to really curb the problem, and should not just rely on like poor farmers bearing the incidence of the entire policy, right? So that's definitely not what I want to suggest.
Time for probably one last question if there's one.
Could I ask a qualitative question?
Yeah, go ahead.
So I think when I read your paper, there was one paragraph that struck me on page 8, which is about there's a less likelihood of things happening when there is greater enforcement of law, right? Which is to say that if people are enforcing law, then people are less likely to do this, the act of burning. So I'm just like purely wondering if we have deeper penetration of state and its mechanism across the country, which is to say that if there's a greater equal spread of law and situation and administrative machinery, is this problem going to be resolved? Is it an argument for greater powers of the state equally distributed?
Well, it's an argument for taking seriously the incentives of whatever administrator you have. I don't know if giving them an all-out authority to put people in jail is going to resolve this problem, because you'd have riots the next day. Or if you put all the farmers in jail, then who's going to produce the food for you? So that's definitely not the
argument. So Foucauldian surveillance state is not the answer.
That's, I don't think, ever the answer for any problem.
Okay.
I would say though, so like bureaucrats, I think, are aware of this problem and thinking very carefully about it. I wanted to do an experiment with the agriculture department in Punjab, and the secretary said to me that what I want from you is machine learning prediction at the farm level of who's going to pollute this coming week, and that is going to be hugely informative for me because I can send my agents out.
Right, that's the course.
And you know, like, I know it doesn't have to be course.
Oh,
It
whatever,
could be
just
like
okay,
some,
yeah.
okay, you know,
Yeah.
I'll give you these seats for cheap, you know, or whatever. You know, like they can strike a bargain.
Yeah.
The problem is bureaucrats, even we academics don't have the ability to do that because satellite data at the farm level exists from a few sources. For example, there's a Planet database. Most social scientists definitely don't have the skills to deal with that massive data set and then do machine learning on, you know, like even this project is already beyond my skills of like doing, you know, data analysis or handling the huge amount of data that exists. So if someone has those skills, I'd love to partner with you to potentially do an experiment where we release this information and then see, you know, how bureaucrats are able to act on the information that's provided to them. So they're aware of it, and there's a lot of policy experimentation happening. It's just that a lot of it just doesn't seem to be very, you know, not really bearing fruit, unfortunately.
So I have one last question before we let everyone go, just because I know there are lots of students in the room, many of whom you're meeting with in the afternoon, but just as a collective enterprise, I know that if I were a grad student, I would look at this and say, this is amazing work, and I could never do it. And so only just because of the amount that it took, which is fine. But, you know, as you've been working in this area, because it's an area in which so many different kinds of work and studies are needed, were there either obvious questions or easily accessible data sources that you would recommend to students who are looking to get into this area that might be kind of first pass places to go and look at least to get kind of inspired without getting too daunted?
And
Well-
also, can you tell us how long this whole thing took? It's good to know, like,
How long what?
the whole project, like.
Oh yeah, so it started about a year and a half ago, and I had almost a computer science undergraduate research assistant. So I would say one thing, I think it shouldn't be immediately clear that grad students can't do this. If you look at every passing year, like the new crop of students have more skills than all of the senior faculty combined. So I think many of them might have already these skills to handle data sets like these. And I think what I would encourage is for people to sort of get more familiar with some of these data as much as you can. Like the FIRES data is available at the daily level, and you can get yesterday's data on NASA's website. So it's bringing all these amazing research opportunities for us from a remote sensing perspective. Then the question is finding co-authors, collaborators. You know, that's the approach that I take, at least in my work. I don't have the skills for doing most of this work, so I collaborate with people who do, and you know that's what successful collaborations are all about.
All right, thank you so much for giving us so much of your time.
Thank you.